On June 30th, 2026, four very different headlines hit the news. NASA launched a daring rescue of a dying space telescope. Rocket Lab bought Iridium for $8 billion. Sony teased a portable, high-powered PlayStation 6. And South Korea dropped over $500 billion on 4 new memory chip factories. On the surface, these sound like isolated events, but they are all symptoms of the exact same crisis. Our reliance on artificial intelligence and global connectivity is crushing our existing physical infrastructure. We've entered the bottleneck era. For decades, software grew exponentially, but code still needs to run on physical materials, and that growth curve is finally slamming into the hard ceilings of physics, thermodynamics, and hardware capacity. Breaking through those physical ceilings requires capital commitments measured in hundreds of billions of dollars. Silicon Valley has transitioned into an industry of physical mass and heavy manufacturing. Right now, the AI industry is paralyzed by a crisis engineers call RAMageddon. We have the software architecture to build smarter models, but we lack the physical memory chips required to run them. The solution is high bandwidth memory, or HBM. Manufacturers bypass physical limits by vertically stacking memory chips, but shoving massive data into this dense 3D space creates intense thermal bottlenecks, keeping these chips sold out for 18 months. The shortage is severe enough that South Korea is investing $518 billion to build 4 massive memory fabrication plants, specifically to keep pace with global AI demand. We see the same physical limits in consumer tech. Sony's hints about a hybrid PS6 run into the difficulty of cramming high-heat, high-power processors into a small, battery-powered form factor. Hardware realities dictate software evolution. Without massive physical capacity expansion and thermal breakthroughs, digital innovation stalls. The hardware bottleneck is only part of the problem. Human biology is proving to be a liability, as seen in the Nissan data breach that compromised thousands of sensitive employee records. Attackers exploited a critical zero-day vulnerability in Oracle's HR software. Oracle knew about the flaw for 13 days before releasing a patch, providing a window for extortion groups to ravage over 100 organizations. Enterprise networks have become too complex for human engineers to secure. We cannot write or patch code fast enough to manage these systems, necessitating the use of autonomous AI coding agents. That human limitation drove SpaceX and xAI to pay $60 billion for Cursor, the startup behind the world's most popular AI-powered code editor. The developer workflow is changing. Instead of typing out code, engineers use mobile apps to remotely supervise fleets of AI agents doing the actual mechanical implementation. Human cognition has become the weakest link in enterprise networks. This massive $60 billion acquisition aims to automate software development to keep pace with the infrastructure's complexity. This physical bottleneck extends into low Earth orbit. The space economy previously relied on disposable hardware, launching billion-dollar satellites and letting them burn up in the atmosphere when they decayed. That model has hit its economic limit. NASA just launched a $30 million mission to physically rendezvous with the Neil Gehrels Swift Observatory and boost its orbit, saving a $500 million asset from destruction. This serves as a prototype for an orbital servicing industry. Companies will send autonomous vehicles to refuel and repair existing hardware, rather than relying on constant replacement launches. At the same time, the demand to route data through these satellites is reaching a breaking point. Rocket Lab just paid $8 billion for Iridium to secure an immediate foothold in this market. While Starlink targets consumer broadband, Iridium provides absolute pole-to-pole coverage. That unbroken reach is required for the logistics and maritime data that keep global trade moving. Space dominance relies on sustaining multi-billion-dollar assets in orbit and securing data links that cover every square mile of the Earth's surface. For 20 years, Silicon Valley prioritized software that was cheap, easily updated, and endlessly scalable. Power has shifted to those who control the physical infrastructure. Success in 2026 depends on owning the heavy industry assets that support the digital world. We are watching global powers fight over $500 billion memory fabs, orchestrate high-stakes orbital rescues, and build supercomputers to automate human engineering. The hard limit is no longer human ingenuity. It is our capacity to build the massive physical structures required to support it.